Welcome friends to my channel nirajkapase. Today we are going to see MQTT contribution. So MQTT is message queue telemetry telegram protocol. It is a widely used protocol in IoT. Again, before starting with this session, if you're not subscribed my channel, please press subscribe button and also press notification bell icon for next upcoming updates and next upcoming videos. Okay, we'll start with the MQTT. So MQTT is an open source protocol and it is uh, preferably used in IoT design and development. Okay, so it is a more popular protocol in IoT. So many of the IoT technologies or IoT application uses MQTT protocol for data transmission and reception. Okay, so why this MQTT is popular? What is the frame structure of MQTT and in detail structure of MQTT we are going to see in this particular video. What is MQTT and all? Okay, so we'll start with MQTT contribution. So with we'll start with the history of MQTT. So MQTT history. So if you look at MQTT, so it rises in or it came into this technology came into a picture in 1999. Okay, so there is a company named as IBM. They have invented this MQTT. So there are two engineers. One is Erlen Nipper. He's from Arcom, and Andy Stanford and Clark from IBM. They invented this particular MQTT, and then in the year 2010, this becomes royalty free. So earlier, the IBM is using this particular technology for internal communication. So they are just transferring the messages over the internal line, and they are using this particular technology for internal communication within a company. So from the era 2010, they made this particular technology, that is message queue telemetry telegram technology, royalty free. So royalty free means it's a open source now. Okay, so open source means you can contribute this technology and you can use it this technology for free of charge. So there is a no charge required to pay for this particular technology. Okay, from the 2013 onwards, the Oasis take over this particular technology. Oasis has taken over this particular technology. So this technology is taken care by Oasis. So Oasis is again a company, and they just taken over this particular technology. From 2014 onwards, so there is a website named as mqtt.org, and the current release of MQTT is MQTT 3.1.1. So currently its latest release is different, but from 2014 onwards the release is MQTT 3.1.1. Okay, so this is about history. So I will repeat these things. So Arcom, that is Arcom, from Arcom, the Erlen Nipper and Andy Stanford Clark, they have invented this particular MQTT in the year 1999. So invention of MQTT is in the year 1999. Then it is made royalty free, that is it is made free of charge or open source from the year 2010 onwards. So in the year 2010 this technology becomes open source. After that, in the year 2013, so Oasis TC has taken over this particular technology. So Oasis has acquired all the protocol structure and all, and they have just taken over this open source technology, and they hosted all the things on mqtt.org. Okay, and from 2014 onwards, the first release was released, that is MQTT 3.1.1. Okay, so that is first release, and current latest release is different. So you can go with open the mqtt.org to get current latest release as well. Okay, so MQTT stands for message queue telemetry telegram protocol. Okay, so it is a publish and subscribe based protocol. We are going to see all details about MQTT. Okay, so this is about MQTT history. Next we'll move forward. What is being contributed in the MQTT? So what is contributed in the MQTT? So MQTT was co-invented by IBM and Arcom Systems. So IBM and Arcom Systems. So Arcom Systems is, there are two companies, and they collaboratively invented this 13 years ago, or in 1999. The current MQTT specifications are available on their website as well. So you can look at this particular website. This website is from IBM developer. So we can have ibm.com/developer/work/website web series/library/ws MQTT and index HTML. So this specifications was contributed over Oasis. So currently this is taken care by Oasis. So Oasis is a company which holds all the contribution of MQTT. It is available under open source royalty free licenses. So this is very important thing. This is available under a open source and royalty free licenses. So it is open source, so no need to pay for this particular technology. This technology is available free of charge for all, and you can use it for your development and this thing. Okay. So abstract from MQTT spec website. What is MQTT? So what is the abstract written on the MQTT specifications? The MQ telemetry transport protocol. So MQ telemetry transport protocol is the name for MQTT. The full name of MQTT is MQ telemetry transport protocol. It is a lightweight publish and subscribe protocol. Why it is lightweight? Like we can have a HTTP protocol, but HTTP requires 512 bytes of a packet size while transmission. But this MQTT size is half than that of a HTTP protocol or that protocol, HTTP protocol. So that's why it is a half size and it is a lightweight protocol. So sorry, it is MQTT is a publish and subscribe based protocol flowing through a TCP/IP, remote sensors and control devices through a low bandwidth. So it works on the low bandwidth, unreliable and intermittent communication as well. So this is very important thing, like it works on low bandwidth. So bandwidth required for the MQTT, because the packet size is light and packet size is very small. So that's why the bandwidth required to transmit the data from one location to another location is less. So it works on a low bandwidth as well. Secondly, unreliable sources as well. So it can hold the data, hold the packet, and if the connection breaks, then also it will hold that particular packet, and once the connection get established, it will deliver that particular packet, or that packet will be retained itself. So that the thing, like whenever there is a connection problem, then the packet is retained and then it's going to delivered afterwards whenever the connection gets established. So that's why it is works with unreliable and intermittent communications also we can do. This protocol specifications not been standardized, so still there is a lot of standardization scope is available under this to standardize this particular protocol, and there are many brokers available for this protocol as well. So this protocol will be used in many of the industries and many of the IoT applications, and it is an open source protocol as well. It is made available under a royalty free licenses. Okay, so it is made under a royalty free licenses. So from 2010 onwards, just now we have seen that it is made royalty free from 2010 onwards. So earlier it is chargeable. It used within IBM only, but from the 2010 onwards it's a royalty free. So many of the person can use this particular protocol for their development and all. Okay, so this is about MQTT contribution. So again, MQTT is messaging for Internet of Things. So mainly it is used for messaging of Internet of Things. Okay, messaging for Internet of Things. What is there in the MQTT? MQTT is a messaging protocol. So it is used for writing a messages or sending a messages over the internet. It is a easy protocol. Okay, again the setting of MQTT is easy. So it is written in a C. So you can read the protocol structure under mqtt.org. You can visit this particular website mqtt.org to get more information about MQTT protocol. Also, it is a minimum overhead. So the data transmission and the packets are less in size. So it works over a low bandwidth as well. Okay, so large amount of internet is not required. So it works with low bandwidth. Then it is a binary protocol. So all the data or all the information is in 0 and 1s format. So we can have a data organistic. Then main thing about this is it is a publish and subscribe protocol. So those who are the subscribers for this particular thing, they will receive all the published information. Okay, so it is works with the technology named as publish subscribe. Okay, so this is about MQTT. What are the use cases of MQTT? So who is going to use MQTT, and what are the things over the MQTT? Use cases of MQTT. Okay, so it is a push instead of a pull. So pushing data, it's very easy instead of a pull. Pulling means you're getting the data from the server, but pushing means you're putting the data onto the server. Okay, so it is a push over instead of a pull. Reliable even when used unreliable networks. Just now I have discussed that it is reliable even when with the unreliable networks. Whenever the network breaks, then also it will retain some data for some time and then it will publish. So it is a reliable one. Okay, all the information is reliable. Whenever there is a issue with a network as well, then it's going to retain the data, and it's then afterwards it's going to publish that particular information. So it is a reliable even when used with unreliable networks. It is used with constrained devices as well. Okay, so it is used with like low bandwidth devices, low power, low memory devices, and all that thing. So it is used with the constrained devices. So it is a low bandwidth protocol. So bandwidth required to transmit or to use this particular protocol is very less. So it is a packet size is half than that of a HTTP protocol. So the full packet width is less, and it is having a high latency. Okay, high latency is there for this particular protocol. It is enterprise for the mobile. So so for transition or mobile nodes, so this is enterprise one. Okay, so this is the thing about MQTT. So that's why it's a MQTT is very popular protocol, and it's been used in many of the industries for the application of this. So this is about MQTT protocol. It is a publish subscribe messaging protocol. So MQTT is a publish subscribe one to many. Okay, so here these are the publishers. So it is a MQTT broker. So publisher publish the information over the MQTT broker. So this is publisher, and it sends the information over the MQTT broker. So many publishers are there. So publishers will send the information over the MQTT broker. Okay, then the subscriber will subscribe for the different messages. Okay, so depending on the requirement, the subscriber subscribes the messages. Like I will give you an example. If you are using a weather app, then there are different sensors and actuators connected for measuring the weather parameters, and they are publishing all the information over the weather cloud. And just we are attaching to that weather cloud with our smartphone, and just we are subscribing that weather information on your smartphone. So like this way, so we are the subscribers and the publishers are the sensors and actuators and the server. Okay, so all the system is known as a publisher, and whatever we are just reading the information, that is a subscriber. Okay, so it is MQTT is publish subscribe messaging one to many protocol. So MQTT is most widely used as publish subscribe messaging one to many protocol. Okay, so this is publish and subscribe protocol, right? Then what is about retained message? So just now we have discussed about it works with unreliable sources as well. It's like whenever the network breaks, then also the message will be dropped and it will retain the particular message. So what is about retain the message? So we'll discuss this. It is last known good value. So it will retain the last known good value. The broker saves last messages over a topic for a topic. Okay, broker is the intermediate, and it stores the last messages over the topic. The client decides if the message is retained. So client decides if the message is retained. So like this, the client has to be there is a privilege that we can turn on and off the reception or retention of the message. The client receives the written message after subscribing it. So whatever the things over the broker, so client will receive all the information like once it's subscribed that particular channel. Then message retention is there. So again, MQTT is publish and subscribe one-to-many protocol. A topic from the namespace. Okay, a topic from the namespace. A hierarchy with subtopics separated by it. So hierarchy of subtopics separated by it. For example, the house publishes information about itself. A house publishes information about itself. So like how we can do or how we can categorize this particular thing, like we can have a country, a house country, a region, then town, then postcode, then about house, then energy consumption. So we can have a separate category named as energy consumption. Okay, then again we have a country, a region, town, postcode, house, and solar energy. Okay, the information about solar energy. Next is the country, again region, again town, again postcode, again house, then alarm state, and this is again also the alarm state. Okay, so like this there are four different subtopics. So we have energy consumption, we have solar energy, we have alarm state, and we have alarm state as well. And subscriber for controlling the commands. So like we can have the country, again region, again town, again then postcode, again then house, then thermostat. So it's again one of the category known as thermostat, and then set temperature. Okay, so like this there are subtopics available under the MQTT. So we can have same root, and that root has been differentiated with the subtopics, and we can put the data over different subtopics as well. Okay, so that is possible under the MQTT. A subscriber can subscribe to an absolute topic or can use a wildcard. So this is important thing, like subscriber can subscribe to absolute topic. So like subscriber can use one of the topic to subscribe, and it can be read over the channel, or we can use a wildcard. So single level wildcards. So single level wildcards plus can appear wherever the topic string, anywhere in the topic string. Okay, multi-level wildcards, a hash symbol must be used and it appears at the end of the string. Okay, wildcards can be annexed to a separator. Wildcard can be annexed to a separator, like all the information will be subscribed, and it will take from the wildcard. It cannot be used wildcards when publishing. So we cannot use the wildcards while publishing, but subscribers can use the wildcards to get the information. For example, UK hands Hursley ESO212JN1 energy consumption. So energy consumption for one house in Hursley. So whereas UK hands Hursley plus energy consumption. So plus means the energy consumptions of all the houses in Hursley. Okay. Then UK Hursley hash 201 hash. So energy consumption of solar, alarm, and house, all the houses all S212. So like this we can use a wildcards. So okay, so the subscribers is having a wildcard. So it can subscribe for full topic, it can subscribe for a particular topic, or it can subscribe for full the information over the region. Like just it's explained here. Is having one house information from here, that is ESO212JN. So it's the pin number of this particular house, and it's just one house energy consumption. So if we write plus symbol, it is energy consumption of all the houses in Hursley. And if it is a hash symbol, then it is the energy consumption of solar, alarm, then all the houses of SO212JN. Okay, so this is about the subtopics and all. Okay, then a subscriber can be a durable or non-durable. The subscriber can be durable and non-durable. So there are two types of the subscribers, like durable subscribers and non-durable subscribers. Durable subscribers, once the subscription is placed, the broker will forward the matching messages to the subscriber. So like once you subscribe that particular information or that particular channel, then the broker has to transmit all the information immediately if the subscriber is connected. Okay, the broker will update all the information once the subscribers get connection. If the subscriber is not connected, message is stored and served on the server of the broker until the next time the subscribers get connect. Okay, so in the non-durable state, the subscriber lifetime is same as that of the subscriber is connected to the server or a broker. So like in the non-durable, so there is a no message retention. Once the subscribers gets connected, it is then only it will send the data. But uh, I will give you a simple example of WhatsApp. WhatsApp is having a server. Suppose if you are not connected to the internet, then also the WhatsApp server will retain your message, and once you get connected, you will the message will be delivered to you. Okay, so that is a durable information. But non-durable, whenever you are connected, then only you will get the thing. Okay, a publication may be a retained one. A publication can be retained. Okay, a publisher can mark a publication retained as a retained. Okay, publisher can mark this publication should be retained or non-retained. A broker or a server remembers the last known good message of a retained topic as well. The broker and server gives the last known good value for the new subscriber as well. Okay, that is, the new subscriber does not have to wait for publisher to publish the message in the order to receive its first message. Okay, so like the last known value can be retained. So it constraint device. So it is designed for the constraint devices. So MQTT is designed for the constraint devices. So suitable for the application with the devices have a main available 8-bit controller upwards, or a battery operated or a very small memory type of devices, and also the low bandwidth devices can be used for this. So constraint devices can use the MQTT protocol. Multiple MQTT clients or implementation is available with different languages as well. So it supports different languages, and multiple implementation of a clients is possible. It's having a tiny footprint of MQTT client and the server. So the footprint of MQTT is very small. It is a tiny footprint, and over the server library that it available in Java library. Also, it's available in embedded C. Okay, so footprint of MQTT is very small. It's a tiny footprint. Okay. So this is about constraint device. So low battery devices can be worked and all. That thing is possible. So there are different brokers available in the market. So MQTT broker. So first broker is PAHO. Okay. So you can Google Eclipse PAHO. So it is developed in Eclipse. Okay, Google on Google you just type Eclipse PAHO and read all the information. So it is a open source. PAHO is open source. Its reference implementation is there. It is active community, so you'll get community support over a PAHO. Sync and async API is available. So syncing and async API is available. So it can support different languages like Java. It supports C, C++, C Sharp, Go, then Python and JavaScript. So these different languages it supports. So PAHO is one of the broker. So named as broker name is Eclipse PAHO. So it's open source. It's having active community. The sync and async APIs are available. Then it supports different languages like Java, C, C++, C Sharp, and Go and JavaScript and a Python as well. Okay. So this is one of the broker PAHO. So next broker is MOSQUITTO. So MOSQUITTO is again one of the brokers. So you can have and it is again open source. So you can Google it for this MOSQUITTO as well. So it is open source, ideal for constraint devices. So it is whenever you are using a battery operated devices or low bandwidth or low powered or 8-bit devices, then you can go with a MOSQUITTO broker. So earlier broker is a little bit more, but MOSQUITTO broker is very lightweight broker. It supports bridging as well. So two different brokers can be bridged together. Okay, implementation in a C. So MOSQUITTO is written under a C. So it supports the C language as well. Okay. So this is about MOSQUITTO broker. Next is a HIVE broker. So again, HIVE broker is a more popular broker. It is a high performance MQTT broker. So performance for HIVE is more. So it is a high performance MQTT broker. It is come up with built-in security in a mind. So security is available for the HIVE. Open source Java plugin system is available for HIVE. Okay, it's open source Java plugin system. It supports bridging as well. Okay, it supports clustering. Okay, HIVE supports clustering, bridging, and designed for enterprise use only. So it uses for industrial use, or it supports industrial use and all. So it is designed for industrial use. So we'll see how you can use this particular broker in different applications and all. Okay, so how you can use this PAHO, how to register with the PAHO, how to register with MQTT, how to use the MQTT protocol, how to use this MOSQUITTO, how to use this HIVE as well. Okay. All right. So this is about MQTT basics. So what is there inside the MQTT, and we have seen. Okay. Then we're going to stop here for today's session. Again, those who are not subscribed my channel, please press subscribe button and also press notification bell icon for next upcoming updates. Thank you for listening. Thank you.